Hello everyone, welcome back. In this video, I want to talk about rational expressions and rational equations, and we're going to start by talking about how to simplify a rational expression. So rational expressions are created whenever we have a fraction involving polynomials, or we have one polynomial divided by another polynomial. And if we want to simplify a rational expression, what we're trying to do is see if there's any common factors that we can cancel between the numerator and the denominator. So to simplify a rational expression, we're going to factor our numerator and our denominator completely or as much as we can, and then see if there's any common factors we can cancel out. If there are common factors that can be canceled, we'll cancel those and then just write whatever is left over. And so let's go ahead and start simplifying this rational expression. In the numerator, we have x squared plus 6x plus 9. And then in the denominator, we have x squared minus x minus 12. And so what we want to do is factor the numerator and the denominator as much as possible. And so when we're factoring these quadratics, we have to remember some of those factoring strategies like what are two values that multiply together to give us constant and add together to give us the linear coefficient. That'll be effective for both of these polynomials. So we have to think of what two numbers multiply together to give us 9 and add together to give us 6. And those numbers are 3 and 3. And so that helps us remember that we can factor x squared plus 6x plus 9 as x plus 3 times x plus 3. Or if we wanted to, we could write that as x plus 3 squared. And so now that we have factored the numerator, let's go ahead and focus on the denominator. We're trying to factor x squared minus x minus 12. We got to play that number game again. We have to think of which two numbers multiply together to give us negative 12, and those same two numbers add together to give us negative 1, or that number in front of x. And so we can think of all different ways to factor negative 12, like 1 times negative 12, or negative 1 times positive 12. You got 2's and 6's, 3's and 4's. And the 3 and the 4 are going to be the ones that we want to use, because if we do negative 4 times positive 3, that'll multiply together to give us negative 12. And negative 4 and positive 3 will also sum or add together to give us negative 1. So that helps us see that we can factor the denominator as x plus 3 multiplied by x minus 4. And now that we are looking at both the numerator and the denominator in their completely factored form, we can see that there actually is a common factor of that quantity x plus 3. So we're going to cancel that factor out and then just rewrite what is left over. And that'll be our final answer, our rational expression in simplified form. In this case, that's going to be x plus 3 over or divided by x minus 4. All right, let's go ahead and look at another example of simplifying a rational expression. This time it's going to be a little bit more complicated. And so in the numerator, we have the quadratic polynomial 2y squared minus y minus 1. And in the denominator, we have the quadratic just y squared minus 1. And so factoring the numerator is going to be a little bit more difficult because that number in front of our squared term is not a positive 1, but a positive 2. And so we can either use like a guess and check method, or we can use a more advanced technique like the AC method if we want to factor that numerator. And so if we are using the AC method to factor the numerator, we start by multiplying the constant term and that leading coefficient together. So 2 times negative 1 gives us this number of negative 2. We then play the number game with this new number of negative 2, or our value of a times c. So we're looking for two numbers that multiply together to give us negative 2. And those same two numbers have to add together to give us our linear term, or our linear coefficient of negative 1. And let's see, it looks like that's going to be negative 2 and positive 1. That'll get that job done. Negative 2 times 1 is negative 2, and negative 2 plus positive 1 gives us negative 1. So now we have to remember with the AC method, what these two numbers tell us is how we can break apart that linear term or rewrite it. Instead of looking at 2y squared minus y minus 1, we're going to rewrite that minus y as negative 2y plus 1y, right? Negative 2y and the plus 1y. Then we still have that minus 1. And the idea now is we've created two groups that we can then factor. The first group is our first two terms, which have a common factor of 2y. If we factor a 2y out of those first two terms, we're left with the quantity of y minus 1. But that quantity of y minus 1 actually is our second group. So our second group we don't really factor, or if we want, we can think of factoring a 1 out of it. And then we can see there's a common factor between our two groups of y minus 1. So we can pull that common factor of y minus 1 out. What's left over from the first group is a factor of 2y. And from the second group, we're left with a constant of plus 1. And so our original little polynomial here 2y squared minus y minus 1 factors as y minus 1 times 2y plus 1. And so now we know how to factor that numerator. We factor it as 2y plus 1 times y minus 1. Remember, the order of the factors doesn't matter. We also didn't necessarily need to use this AC method. We could have just kind of guessed and checked and figured this out. But either way, we got to get that numerator factored, and we also have to get the denominator factored. So y squared minus 1 is that very special pattern that shows up all the time. It's that difference of squares pattern. And so that'll actually factor very nicely as y plus 1 times y minus 1. And that's great, because now we can see that there actually is a common factor of y minus 1 showing up in both the numerator and the denominator. We can cancel those factors out, and they turn into a kind of hidden factor of 1. But really what's left over is this quantity in the numerator of 2y plus 1. And in the denominator, we just have y plus 1. So that is our final answer. That is our original rational expression in its most simplified form. Welcome back, everyone. In this video, we're going to talk about adding and subtracting rational expressions together. And so when we're adding or subtracting rational expressions, we're really still just adding and subtracting fractions. And we have to follow all those rules that we have for adding and subtracting or doing arithmetic with our fractions. And one of those is, if we're adding and subtracting fractions, we've got to have a common denominator in order to do so. And so that's what's required when we're adding and subtracting rational expressions as well. So in order to find the common denominator between our rational expressions, we need to look at all the factors that make up the denominators of our starting expressions. And so that means we need to factor every denominator as much as possible. Looking at the rational expressions we have involved here, the second two already had their denominators factored. So we really just have to factor that first one, x squared minus 9x plus 18. To factor this, we have to think of two numbers that multiply together to give us 18. And those same two numbers add together to give us negative 9. And those are going to be negative 3 and negative 6. So now that we have our denominators factored completely, we can see that the least common denominator, that is the denominator composed up of all the unique factors of the original denominators, is just going to be x minus 3 times x minus 6. And so now we have to build up the second and third fractions or rational expressions so that they have x minus 3 times x minus 6 as their denominator. And so our first fraction or rational expression, we're just going to rewrite, not change. It's still negative 6 over x minus 3 times x minus 6. But now our second rational expression or fraction, it started as 1 over x minus 3. It had one of the denominator factors needed, but it was missing the second factor of x minus 6. But when we're manipulating expressions, we can really only do a few things, like add by 0 in fancy ways or multiply by 1 in fancy ways. And so if we multiply by x minus 6 in the denominator, we have to multiply by x minus 6 in the numerator as well. That way, overall, we're really just multiplying by 1, which isn't changing the value of the expression, just the way it looks. We're doing something similar over here for our third rational expression. It's missing the factor of x minus 3. So we have to introduce that missing factor of x minus 3 to both the numerator and the denominator. So after rewriting all of our fractions with the least common denominator of x minus 3 times x minus 6, it's going to look something like this. And now that we have a common denominator, we can write this all as one fraction over x minus 3 times x minus 6. What is our numerator going to look like? It's going to have a term of negative 6. It's also going to have a positive x and a negative 6 involved there. And then it's also going to have 2 times x minus 3. And we can expand that now or later. We have to distribute that factor of 2 to pick up another positive 2x in our numerator, and then also distribute that factor of 2 to negative 3 to pick up a constant term of negative 6 in our numerator. And so we're still simplifying here because we can cancel and combine some like terms. Let's see what we got. So we have a total of 3 x's in the numerator, and then negative 6, negative 6, negative 6 is negative 18. And so that's looking like 3x minus 18 over x minus 3 times x minus 6. But we can actually take this a little bit further, because now we can notice in the numerator here, there is a common factor of 3. If we factor a 3 out of 3x minus 18, we're left with a quantity of x minus 6, which is great because that factor or quantity of x minus 6 is also showing up as a factor in our denominator. And so now we can cancel it out. And now there are no more common factors that we can cancel out, so we're done. And our final answer is looking like 3 over the quantity x minus 3. So our original sum of 3 rational expressions actually simplifies very, very nicely to just 3 over x minus 3. And so this is why it's worthwhile to see if we can combine and simplify rational expressions. If we wanted to evaluate this for a bunch of different x values, there's lots of arithmetic involved. However, we took the time to simplify it and then evaluate the new, simpler version of our expression. It's a lot quicker and easier to use.